Welcome, everybody. This is chapter 22, all about oxidation and reduction. We call it redox for fun. And we're going to talk all about our oxidation numbers. And like the big thing here is knowing that we have our redox, which is the redox right here. Well, redox. And we are going to talk all about our oxidation numbers and how they all come to be. So, first, let's review. Number one, back in chapter 5, we learned that atoms rearrange when we did all of our lovely little electrons. Remember, we have our different 1s, 2s, 3s, 3p, etc., etc. Well, now we're going to look at how these electrons rearrange each other with each other in order to make different chemical processes happen. In order for us to really relate to how these things work, we're going to look at all of our electrons. Electrons are key to everything. So the big thing here is how we can assign oxidation numbers. We are basically going to look at how the electrons and the different ionic charges are going to either be gained or lost in their oxidation numbers. Oxidation numbers are kind of like charges. They are numbers that are assigned to the atoms in molecules. So when we are sharing our electrons, to show that general distribution of the electrons amongst the atoms that are all bonded together. It's a way that we can account for all these different things to happen. So there are several rules, 8 in fact, for assigning oxidation numbers. And a lot of them follow the rules that you know for assigning your charges. So we'll kind of play with that. Rule number one, all uncombined elements have an oxidation number of 0. They don't have any sharing of electrons going on. So whether it's a metal, a diatomic element, some little conglomeration like phosphorus or sulfur, they are all 0. Rule number two, all the charges in a formula must add up to 0. They must be neutral. Obviously, we know all about that. Na and Cl will be a 1 plus and a 1 minus. MgCl2, Mg will be a 2 plus, and each chlorine will be a 1 minus there. So we are kind of reviewing those lovely little ionic charges that we already know. Rule number 3. We are going to take all of the group 1 metals, and they will always, 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 and forever be a 1 plus. Li will always be a 1 plus, and since chlorine will cancel that out, chlorine has to be the 1 minus. K will always be a 1 plus, and since sulfur has to cancel that out, it will always be a 2 minus. Rule number 4. Ooh, it's a little too thin. All group 2 metals, those would be our alkali earth metals, they will always be a 2 plus. So strontium is in column 2, so that will end up being a 2 plus. Chlorine then has to cancel it out and make it negative and neutral. So it will be a 1 minus. Calcium's a 2 plus, so oxygen has to be a 2 minus. Barium's a 2 plus, and since there are 3 of them, totaling a 6 plus, this has to be a 6 minus. 6 divided by 2 gives us a 3 minus charge for our nitrogen. We know these rules. We know ionic bonding. Rule number 5, fluorine, the most electronegative element, is always, 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 and forever going to be a -1. So it will dictate what everything else is. So fluorine's a -1, so hydrogen has to be a +1. Fluorine's a -1, calcium is a 2 plus to cancel it out. These are all, like I said, things that we have gone over in a lot of detail. Rule number 6. Hydrogen will always show up as a charge of 1 plus, except when it's a hydride, when it acts as a 1 minus, depending on who it is bonded to. So hydrogen here is a 1 plus, so chlorine has to be a 1 minus. Fluorine supersedes this in the rule hierarchy. So this is an F minus and this is an H plus. Li is a 1 plus, so H is a 1 minus. Calcium is a 2 plus, so hydrogen here, the hydride ion, remember we have H minus, will be a 1 minus. Rule number 7, oxygen shows as a charge of 2 minus, except if it's peroxide. Remember, peroxide is O2 2 minus. So if you divide out each one of the oxygens, it makes a total of a 1 minus for each oxygen there. So that's your 1 minus. And if oxygen is bonded to a halogen, it will be a 2 plus because the halogens will be the more electronegative and get the actual charge. So we will see down here, we have our H2O. So we have a 1 plus and oxygen is a 2 minus. H2O2, hydrogen peroxide. Hydrogen's a 1 plus. So each oxygen here has to be a 1 minus. And this is iodine here. Don't let the font fool you. Iodine's a 1 minus. So oxygen here will be a 2 plus. And then perhaps the trickiest but the most important rule is that if you have an element that's found in a polyatomic ion, remember those? Oh, we go over those so much. All of the oxidation numbers have to add up to that ion's net charge. So you have to know the charges of your ions. That never goes away. So here we have carbonate. So carbonate is CO3, 2 minus. This whole thing is a 2 minus charge. Knowing the rules for our other elements, oxygen is going to be a 2 minus oxidation number. I have 3 of them, giving me a 6 minus charge, but it is 2 minus overall. So in order to cancel out the charge here, carbon has to be a 4 plus. See how we added up to a 2 minus here? For phosphate, PO4, 3 minus. Oxygen is going to be a 2 minus because that's our rule. We have 4 of them, so it gives me a total of 8 minus. But the net charge is a 3 minus. So 8 minus 3 means that phosphorus is going to be a 5 plus. And last but not least, here is permanganate. Permanganate is MnO4 1 minus. Oxygen will be a 2 minus. There are 4 of them to give me an 8 minus. 8 minus the 1 overall net charge means that manganese, yes, you did it, is a 7 plus oxidation number. So we have lots and lots of these lovely little examples on our next slide. So you have to kind of go through the rules. If it's ionic, it's pretty easy. You know how to do that. If it is covalent, like a polyatomic ion, then we need to do the rules where it adds up to the net charge. So K plus, because it's in column 1, chlorine is a 1 minus to make it neutral. Na is going to be a 1 plus, and then that leaves hypochlorite. Hypochlorite adds up to a 1 minus. So we need to make sure that we know the oxidation numbers for each element in the following. Every capital letter is a new element. Oxygen is a 2 minus, so that means that if we want this to be a 1 minus overall charge, chlorine here becomes a 1 plus. HF, fluorine is a 1 minus, H is a 1 plus, easy peasy lemon squeezy. Zinc oxide, zinc is on our diagonal, so it's in column 12. It is a 2 plus, oxygen is a 2 minus. Tungsten chromate, what type of tungsten is this? Well, we know the charge of chromate is a 2 minus, so this tungsten has to be a 2 plus. And when we look at the individual atoms in our chromate, Oxygen makes a 2 minus for its oxidation number. So 2 times 4 gives me an 8 minus, minus that 2 here. So chromium in chromate here has to be a 6 plus. For sulfuric acid, H2SO4, H is a 1 plus, and then we have sulfate, which is a 2 minus ion. If we look at each individual atom in there, oxygen gets a 2 minus charge. 2 times 4 gives me an 8 minus overall. 8 minus 2 means that sulfur is a 6 plus. Here we have oxygen difluoride. So we have fluorine, which is the emperor of all of our electronegativities, with a 1 minus. So in this case, oxygen is a 2 plus. For hydrogen, it's just hydrogen by itself, not bonded to anything, even though it's diatomic. Oxidation number of 0. Magnesium phosphate, Mg's in column 2, so that's a 2 plus. Phosphate here is a 3 minus charge. So don't let this 2 fool you. That's just telling you the charge of this. So oxygen inside of this phosphate is a 2 minus. 2 times 4 gives me an 8 minus overall. 8 minus subtracting the 3 overall charge means that phosphorus is a 5 plus. And then down at the bottom, sodium perchlorate. Sodium's in column 1, so that's a 1 plus. Perchlorate is a 1 minus ion. And if we do our charges on the inside, here is our 2 minus for oxygen. 2 times 4 gives me 8 minus. 8 minus minus the 1 will give me chlorine with a 7 plus. So those are our oxidation numbers. And as you can see in the notes, over on this next slide, I go through and I make sure that you have the correct number so that you can practice these on your own. So here we are. Welcome. And I hope you have learned some of your oxidation numbers. On our very last slide here, we have our periodic table with oxidation numbers, and they follow the general rules that we have seen all throughout. Everything in column 1 is a 1 plus, everything in column 2 is a 2 plus. Hydrogen can go both ways though. Then we have no numbers for most of these. If you get to AP Chem, you'll learn about those. Our halogens will be our 1 minus, oxygen's a 2 minus, and everything else will go and follow in place. On our periodic table, we know aluminum, zinc, and silver will be our lovely little diagonal with our 1, 2, 3 in columns 11, 12, and 13. And in general, we see this distribution with fluorine with a 1 minus and others all throughout. So welcome to redox and the beginning of a beautiful electronic relationship.